Okay, we're going to do one more rational inequality. This one's going to be a little bit different because it's not going to be set equal to 0 right away. So there's going to be a step added. So the problem that we are going to do is going to be x squared plus 4 divided by 2x minus 6 is less than a negative 4. Okay, doesn't look like too much of a big difference, but we do want to make sure that our problem is set equal to 0, or on one side of the inequality there is a 0. Just kind of makes things a little bit cleaner. Okay, so we're going to start by adding a 4 to each side of the inequality. So now we have this. Now the problem with this is that I have a fraction, my rational expression, plus a constant. So what I need to do in order to find my critical points is I need to get everything over a single denominator, which means I need a common denominator. Now, strangely, I always found that finding common denominators was way easier once we started doing rational expressions rather than traditional fractions with just numbers, because you didn't have to really go for a lowest common denominator. Okay, so my common denominator for this particular expression would be 2x minus 6. So we need to change our 4. So it says this. Okay, and then, so that means I now have the same denominators. So I can rewrite my problem like this. Okay. So now what I need to do is I need to simplify the numerator to see if I can find my critical points. So let's distribute and find some like terms. Okay, so we distributed the 4. Okay, so now I have 4 minus a 24. Okay, so I need you to remember something from last time. A critical point is where the function equals 0, or in this case, the numerator equals 0. Okay. And then, secondly, a critical point will occur where the function is undefined. Okay, or in this case, where the denominator is equal to 0. Okay, so let's take a look at the numerator and let's take a look at the denominator. So x squared plus 8x minus 20 is equal to 0. Okay, that very nicely factors. I need to think of two numbers that multiply to negative 20 but add to give me positive 8. So that would be 10 and negative 2. Setting both of those equal to 0. Okay. So I get x is equal to negative 10 and x is equal to positive 2 so for some critical points. Now I have to take care of my denominator. Now remember, since this is where the function is not defined, okay, these will always get open dots. Okay, so we'll take our denominator, set it equal to 0 and solve. Okay, our function is undefined at x equals 3. Okay, so now let's put these on a number line and see what gives us a true statement. Okay, so now when we plug into our number line, what I'm going to do is I'm going to use this particular version of my function because I think you'll find it's just a little bit easier to work with. You might also, okay, up to you, want to work with this version of your function. Okay. All right, because I think the second one where it's factored might be easier for you to deal with. Okay, we can try them both if you'd like. Okay, I'll probably just stick with this one. Okay, so I need a number line. Okay, and remember on your number line, you have negative infinity all the way to your left, positive infinity on your right-hand side. Okay, so we need to make sure that we're putting our numbers in order. So negative 10, 2, 3. So we're going to choose numbers in each interval. So we're going to pick one between negative infinity and negative 10, between negative 10 and 2, between 2 and 3, and between 3 and infinity. The numbers that you choose are up to you, but I would highly recommend to make your life as simple as you possibly can. So if I'm going to choose between negative infinity and negative 10, I'm going to go negative 20. Okay. Then let's see, between negative 10 and positive 2, let's go 0. All right, between 10 and 3, I'm going to go 2.5. Okay, and then between 3 and infinity, I'm going to go 10. Okay, now I'm going to use this form of my function, and I want you to pay attention to what I'm doing with the signs. Okay, so if I plug in a negative 20 for an x, I get negative 20 plus 10. Well, negative 20 plus 10 is a negative number. Okay, and then negative 20 minus 2 is also a negative number. 2 times a negative 20, that's a negative 40, and then minus 6, that's another negative number. Now, I know it's negative 46, but the question is do I really need to know that information? So I have a negative times a negative, which is a positive, divided by a negative. Well, a positive divided by a negative is always negative, and negatives are always less than 0. So this portion is true. So close dot, and then shade. Okay? So I'm just by thinking of the signs rather than the actual value, it can kind of speed you up. So if I plug in a 0, I get 0 plus 10, which is a positive number. A 0 minus 2, which is a negative number. And 2 times 0 is 0, negative 6, that is a negative number. So I get a negative times a positive, which is a negative. divided by negative, positive number, less than or equal to 0. That is false. Okay. All right. So don't shade there. All right. So let's plug in 2.5. So let's see. X plus 10, 2.5 plus 10, that is a positive number. 2.5 minus 2, that is a positive number. 2 times 2.5 is 5 minus 6, that is a negative number. So I have a positive divided by a negative, which is a negative, which is less than or equal to 0, which is true. So I'm going to shade. Now careful, the 2 gets a closed circle. The 3, since it's the critical number that makes your denominator 0, always gets that open circle. So I'm going to shade. Okay, now let's plug in our positive 10. Again, thinking of the signs. So 20 times an 18, that's positive times positive, and then divided by a positive. Positive divided by a positive is a positive. Less than or equal to 0? Nope, that is false. All right, so we don't shade. So our answer in interval notation will be this. Remember, infinities always get a parenthesis. And there we go. That is beautiful. All right, so next up is the word problem. Now, I'm going to pull the word problem directly from your homework, but we're not just going to set it up, we're going to solve it. Okay? All right, thank you.